Agriculture, the world's most vital industry, is on the verge of a digital makeover. On Interconnected, a new show by Equinix that explores the hidden infrastructure behind our connected future, they explore the ways edge computing, AI, and other modern innovations are reshaping how food is grown, sent, and delivered. Global agri-food leader Christine Gould lays out the digital challenges farmers face and where change is already sprouting. Listen on Spotify or wherever you get your podcasts.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. We are already halfway through October, and it's hard to believe, but we're starting to plan our end-of-year shows, so stay tuned. More details on that coming soon. As many of you may have noticed, we've been digging into Agentic AI more and more on the show recently. Some of that, I admit, is my personal interest, but I'm always curious as we see new trends, how and where they are actually being implemented in production, and if that use case will stick long-term. So AI coding really has jumped front and center this year, with more and more use cases emerging that not only have traction, but also real revenue behind them. And that got me thinking, what's the next step or impact for Agentic AI after code creation? Well, that's the topic of today's show. We will explore how Agentic AI impacts software quality through predictive code simulation. This is helping a lot of teams switch from reactive debugging to proactive problem prevention. And all of that is coming up right after this break.
Today's show is brought to you by TestCube. Testing applications in Kubernetes doesn't have to be complicated. TestCube is your go-to platform for cloud-native continuous testing. With TestCube, you can orchestrate, scale, and automate tests effortlessly right within Kubernetes, catching issues early and deploying with confidence. Try it out today and see why engineering teams trust TestCube to keep their testing simple and scalable. Your test, your tools, your infrastructure, finally together. Check it out at testcube.io/cloudcast.
And we're back. And this week we have a really good topic to dig into because we've been talking a lot about the evolution of AI and going into also this agentic AI era, But also I wanted to talk about one of the biggest use cases that's out there is specifically for coding, but I want to dig a little bit deeper than normal. What does that really mean when we start really talking about coding and agentic coding, and how does that really affect software quality overall as well? And so for that, we have Animesh Koratana, Player Zero founder and CEO. So Animesh, welcome to the show.
Thanks for having me. I'm super excited to be here and really excited to dig in.
Absolutely. So give everyone a brief intro to your background and your involvement in Player Zero, please.
Yeah, absolutely. So we started Player Zero a few years ago. My background's primarily in research, and many years ago we were working on model compression and inference algorithms. This was in a pre-ChatGPT era, and just by virtue of the research we were doing, we got exposed to one of the first iterations of these large pre-trained transformers. It was GPT-2 that OpenAI had just trained. And that was the first time that we got to see language models writing code, just computers writing code, right? And before that wasn't even feasible, right? I mean, our like imaginations didn't even go that far. And so it completely blew our minds. And at that, like from that moment forward, basically, I was pretty obsessed with this idea that, as we stepped into the future, more and more of our code bases would be written by AI. And in a world where that's happening, a lot of questions are basically going to be asked about what happens next, right? Like what happens after the code is actually generated, after it's in production. If no humans actually understand it, how do we fix it? How do we maintain it? How do we operate that software? I think anyone who's been around software for long enough will tell you that most of the work actually happens after it's left the editor. And so that's really what we're about at Player Zero. I think there's this very interesting pattern that's emerging among almost every single one of our customers and every single one of our, the engineering leaders that we get an opportunity to talk to, where everyone's just really thinking about what's next, right? Everyone's adopted Cursor and Windsurf and Copilot, and I think there's some really cool new things with Claude Code and Codex all happening. But at the end of the day, these things are just really built to help you write more code faster. And I don't think there's enough of an attention placed on basically how do we make sure that this is, high quality.
Yes. Well, and I'll add to it too, maybe just to, double click into that, this idea of like, okay, predictive software quality, but also too, like, you'll hear things in the industry of like, okay, everything from, I took this code agent and set it at the software and it solved this bug that's been in the, software for years and no one ever kind of knew about it or never knew how to solve it, or, these big refactoring projects. But then you also get, it's no better than like a junior developer at best because it writes really horrible spaghetti code. And so like you get all of these different things kind of, you get all over the place, not only in the impression of what it's generating, but also obviously the quality of all of this. So tell everyone a little bit more what that means of like, okay, when we say software quality, like, what does that mean? Like at its very core, what's the definition, right?
That's a really good question. I've spent a lot of time sharpening what I really think good software quality is. And I think what I realized is that quality is not an action, it's a process. And it's something that's embodied in the way that we actually build and develop and maintain software. It's a part of the development lifecycle. And I think to say this another way, the process is defined as something that it's defined as how do we learn about how our software actually runs out there in production, and then bring that to be a part of how we build software in the future. I think a great analogy for this is, thinking about some of the best software teams in the world are the ones that they're almost magically fast at solving problems when they actually happen, a bug, an incident, whatever it may be. And then it becomes a part of the way that they work every single day for the rest of their life, right? Like they make sure and they're maniacal about this to make sure that same problem never happens again. And so there's this kind of memory that accrues for each software kind of engineering team that's built over the life of the product and the software that they're building, that remembers and kind of adapts to how that software is actually used and the expectations that the business has against that software. And that memory, I think, is really where software quality lives.
I love that. And maybe a follow-on question to all of that as well, because you have this concept of, okay, we can create the code and there's a certain amount of like, okay, simulating and what does it do? And then there's the testing of this, and it could be unit tests, it could be big tests. Like tell everyone what makes code, I'll use the term agentic code simulation, right? Like what makes it different than say just traditional testing that's out there?
That's also a really good question. So code simulations are one of the most unique things that Player Zero does. And the idea behind code simulations is that you can actually take real customer scenarios, kind of described in plain English, and then simulate them against your code base and basically say, okay, well, I expect the code to do this. Let's go trace through the code, essentially dry run it line by line, and predict how the code will actually behave under that particular state, under that particular situation, and does it actually behave the way that we expect it to? Now, I think what's really important about code simulations is that you're not actually compiling or running the code. And so traditionally, when you think about testing, you think about unit tests, integration tests, end to end. There's the whole category here, but generally, what you're trading off here is unit tests tend to be very granular, right? So you're testing a very kind of small sliver, maybe a function or a set of functions, kind of all working together. And then once you get to the other kind of degree of coarseness, which might be end-to-end testing, right? You're talking about testing just a few things, but maybe testing the happy paths, right? Does the button just work correctly or not? The reality is like most of the issues actually happen somewhere in between. They happen where the system is in a particular state, and when that state happens, and then you click these 2 or 3 things in that way, then the system breaks down, right? It doesn't work the way we expect it to. And so actually just getting the system in the right state in order to test it, right? You have to get all the data in the right state, spin up multiple servers, all these different things. It becomes incredibly difficult, incredibly tedious. And so the natural answer is like, let's just do less, right? Let's just do less testing. Like, let's be more, stingy about what we actually end up verifying. And the power of code simulations is that you don't actually have to be constrained by that anymore, right? You can write your expectation in plain English, basically paste in a PRD if you want. You can automatically generate it if you want, and then you essentially just go and simulate it. So let's assume that these three, servers are in this state, or this is the record that's in the database. How would the code base actually behave? And you can get a ton of leverage that way, right? You can do what otherwise would have taken, a few weeks. Probably get it done in a few hours.
Yeah, and I like your use of the word tedious. I think that that really sums up a lot of what we were talking about here. But also you mentioned like, okay, hey, here's the PRD, and you can kind of simulate some of these other things. But it immediately makes me think of like, okay, this goes above and beyond just basic developers, right? Because if I kind of do a software workflow, I mean, there's developers, there's QA, there's product managers, there's even support teams. So there's folks in front of developers and there's folks behind developers if I make a supply chain out of all of this. And so how does Player Zero kind of interact and work across all of those different roles?
Yeah, so there's really two workflows that we plug into. The first is defect resolution, and so this basically starts when a customer tells you, "Hey, the thingy broke," right? They create a support ticket and they're like, "Hey, this thing broke," and then begins the entire journey of what broke, how did it happen, like where did it happen, what do I need to do in order to fix it, all the way down to the line of code and the patch that actually goes and fixes the problem. And so, that use case primarily is driven by support engineers. So this is, L2, L3 support, sometimes, a faction of the engineering team itself, right, getting involved in this. And what Player Zero enables is a world where, the support folks can actually take the ball, so much further, right? They don't have to get engineering involved as early, but they have a lot more agency to be able to, test and iterate on different hypotheses, talk to the code base and say, okay, well, does this actually work the way I expect it to? And ultimately even get to some sort of resolution, right, without having to involve as many people. And so that's the defect resolution workflow. The second workflow that we also are really good at is defect prevention. And so this tends to be, primarily driven by QA and engineering teams, where we're actually listening for the changes that development teams are making as they're building a new feature or something like that. And then we say, okay, well, we have this pulse of all of the things that have broken in the past. And based on the changes that are being made right now, how do these changes, or could these changes reintroduce these problems that we've, seen in the past? And then we go pull those things in and then we go and simulate them. And then we say, okay, well, based on these changes, it looks like you actually broke this thing from, 3 years ago, right? And you might be reintroducing this. Here's what the fix should be. And then we'll automatically go and heal software that way. And what we realized is, these are actually two sides of the same coin, right? I think a great analogy for this is thinking about it kind of like an immune system for your software, right? If your software is kind of growing and expanding at a rate that we don't fully deterministically understand anymore, and I think that's happening with AI, Player Zero kind of layers in as an immune system on top of that, to say, okay, well, let's prevent the bad things from coming in, and then let's make sure that we're healthy going forward.
I like that. So Animesh, let me ask you this, because I guess maybe too, like folks out there, and again, this is the challenges of audio and podcasting at times, and us not necessarily like, hey, we were talking about it before we hit record, like, hey, we don't have a whiteboard, but let's talk about like integration and workflows and kind of get very practical for a second here, because a lot of folks, a lot of our listeners out there, they're probably wondering like, okay, you've got this thing that's kind of, simulating things, but at the same time, like I've got these existing CI/CD pipelines, I've got development workflows. And so like, what does an implementation look like? Is it next to what's already out there, or does it somehow fit into the pipelines? Tell everyone a little bit the practical aspects of the architecture, if you will.
Yeah, absolutely. So, kind of two different ways to go about this, right? One is, what type of data does player zero actually sit on top of, and the second is, well, how does it actually fit into the workflow? So on the data side, right, the most important type of data that we've talked to is your code base. And so one or more, code bases that you can actually plug in. We support any language, every single one of the major SCM kind of players, GitHub, Azure, Bitbucket, all that stuff. So that's your code. The second is we plug into your ticketing system. This could be, your internal ticketing, think, Jira, Linear, stuff like that, or even external ticketing, so like Salesforce, Zendesk, ServiceNow, that sort of stuff. And that gives us a pulse about like what's actually happening out there. What are your customers saying? What defects have happened? What bugs are being worked on? All that kind of stuff. And then the third and final is your telemetry system. And so this is optional, but some customers actually point their logs and traces to player zero, just as a way for player zero to get a sense of how does the theory of the code connect to the reality of the runtime. Right? What are the actual states that the code finds itself in? And we use that to basically reinforce certain beliefs that we have about the code base and the architecture. And so all these things come together to basically power these two workflows that we were talking about earlier, but tangibly kind of in the like how this actually looks. For the defect resolution workflow, it's most of the time in response to a ticket. And so you'll have these agents basically spin up every time a new ticket or a defect is mentioned in your ticketing system. So imagine a customer complains something, shows up in Salesforce, right? Player zero can automatically just spin up, go and do the analysis, go test a few hypotheses, come back and say, hey, here's the root cause, here's the fix, and then an engineer can basically review. And on the other side, to your question about CI and how do we actually kind of integrate into that workflow from a prevention standpoint, we basically fit directly into the CI workflow. And so anytime a code change is made, we can basically trigger our agents again to say, let's do an analysis of the changes that were just made, pull in the right scenarios that should be simulated, simulate those, give you the feedback, and then if that show you directly in the workflow itself. Right? The idea here isn't to create a whole new way of working. I think it's to say there is a different way that we should actually go about this in the AI native future, and trying to build the AI native version of verification and quality in the development lifecycle.
Yeah, I really like that final point of the verification and the quality, because I think that's the key thing we're looking about here. But then also to my one more implementation question, my mind immediately goes to like, okay, great. Scale and complexity, right? Like how do you handle really large distributed systems with lots of microservices or, potentially a bunch of databases or, it takes me back to like the early days of containers where it was like, hey, everything was great as long as it was ephemeral, right? And as soon as we had data and persistence, everything got really hard, really quick. And so tell everyone a little bit about the nuances, if you will, of how to handle these distributed large services.
Yeah, no, that's a great question. And the reason why it's a great question is because that's actually a lot of the reason why we built CodeSim to begin with. So one of the big challenges that we were facing internally is in order to run agents, you have a distributed set of services, and we ended up having in the order of like a few dozen services at just a startup like ours. And our customers were orders of magnitude even bigger, where our biggest customer here has like about 1.5 billion lines of code written in about 15 different languages, 850 repositories, right? It's incredibly difficult to actually, understand state and understand even, like how one specific thing happens in a code base of that size. And so we had to, invest really heavily in actually building our code base understanding models, for example. So we actually, under the hood, we actually built this like massive semantic graph of how multiple different types of code bases all come together. And you can actually traverse this graph at different levels of granularity. So at the lowest level of granularity, you can imagine like functions calling each other, and this function calls that function, that function calls this class, like all of those different things. But you can imagine higher levels of granularity saying, okay, well, these are features that tend to co-occur. or these features architecturally talk to one another, or like message broker architectures. And like you can actually represent all of these different things in this really large graph. And then we are able to traverse that graph at any scale to be able to, answer, trace, simulate these really kind of complex queries over these large distributed code bases. And so from a technology standpoint, right, this is basically how we, handle code bases of that size. But I think the other, I think, notable piece here is code simulations were actually built to deal with that scale. And I think another great way to think about this is like if you have 800 repositories and 800 different services all interacting with one another to create one particular outcome, in order to test one specific scenario in that code base, you would basically have to spin up 800 servers and then get all of them in the right state and then get the database in the right state and all of those different things, synchronize it, and then only would you be able to reproduce a particular scenario. But with a code simulation, we're not tied to any sort of infrastructure. And so we could actually, just trace through the code and say, okay, well, in plain English, let's just assume the database is, in this state, and let's assume that the services are, all up and healthy. Now let's go and, just trace through the code. And so it ends up, again, condensing a ton of this tedious work that we have to do for every single thing that we have to verify into basically the parts of verification that really require human judgment. Right? Like we basically get to exercise our judgment 2 orders of magnitude more than we ever were able to, because we're just not stuck messing with infrastructure anymore.
Yeah. And it reminds me, a story, and it's sort of related to this, but it was more, the original story was more around economies of scale and cost to spin something up. But I won't share the customer name, but a very large financial institution here in the United States. I was talking to them at a conference, and we were just kind of like at a happy hour chatting away, and they were telling me this story about like, hey, we have this web front end. And anytime we want to make a change to our web front end, we have to spin up, I forget how many servers it was, and get the databases. And it took basically like a week, and it cost them basically about $500,000. Yeah. Anytime they wanted to just go through one test of their web front end, like make one little change. And so like it like this immediately came to mind of like, okay, just like the savings of cost to spin things up, the cost of people and resources, and just the time to do something like that. I mean, there's such a huge savings in something like that. So that's super helpful. I think that's a great place to close us out today, Animesh. If someone out there is more, interested in this and wants to get started, what's the best place to start?
Yeah, absolutely. So I mean, the best places to reach out is our website, playerzero.ai. You can book a time with us, or even just get started directly. Super quick, plug in your code base. You should be off to the races, being able to run these simulations, debug real problems in just a couple of minutes.
Fantastic. Yeah. Well, Animesh, thank you very much for your time this week. And for everyone out there that's listening, thank you very much for your time this week as well. If you enjoyed the podcast, please tell a friend. Please leave us a review if you can leave a review wherever you get your podcasts. And of course, we're always welcome for feedback as well. And we're always interested in guest ideas and topics. And that is, of course, show@thecloudcast.net. And again, everyone, thank you for listening. And we will talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.